Hello guys, in this lesson we're going to demonstrate how to configure multiple routers via a terminal server using reverse telnet. This lab will consist of 4 routers. We're going to place 3 routers of the 4331 type, like so, an 1841 router, which is going to act as our terminal server, and a PC that is going to function as our client. Next, I'm going to rename the 3 backend routers to router 1. Okay, I'll do a bit of a trick, so I'll make it like so, and then put router 3, router 2, and then router 1. I'm going to click on the magnifying glass just so that everything is more visible. Okay, perfect. And next I'm going to double click the terminal server, power it down, and then I am going to click and drag the HWIC-8A module and then power the device back on. Navigate to the CLI of our terminal server, and while it's doing that, we can actually deploy our network media by attaching a copper straight-through cable between our PC and our terminal server. However, the default fast Ethernet interface of this router will actually not support a straight-through cable, so instead I'm going to use a copper crossover cable and connect the two like so. And then we're going to connect our terminal server with each one of the backend routers using octet cables, which are going to be connected between the async interfaces of our terminal server and the console ports of each backend router, like so. Next, I'm going to double click our terminal server, run no, enable conft. First, I'm going to do the easy part and configure the gigabit Ethernet interface facing our PC, which is fast Ethernet, actually 0/0, and I will give an IP address of 192.168.1.1 followed by a subnet mask of 255.255.255.0, and I'm going to bounce it, no shutdown. And now if I run the command show line, if you notice, the first 3 async ports are labeled as 18, 19 and 20, and you can see that port 18 is connected to router 1, port 19 is connected to router 2, and port 20 is connected to router 3. So what I'm going to do is I'm going to go back to the global configuration mode of our terminal server, and I'm going to run line 18 to 20. Then I'm going to configure a password of secret, login, and then I'm going to run transport input all. I'm going to commit my changes to memory, close this window, open up our PC, assign it an IPv4 address of 192.168.1.10. The default /24 subnet mask is the one we need, and its gateway is .1. Okay, and finally I'm going to fast forward the time to make sure that all of our changes have taken effect. And if we have done everything correctly, I should be able to configure all of the 3 backend routers through the terminal server from our client, the PC, using reverse telnet. So I'm going to open up our PC and fire up a command prompt, and I'm going to run telnet 192.168.1.1, which is the IP address of our terminal server, 2018. The reason why I didn't specify the 18th port that is connected to router 1 is because Cisco, for this configuration, uses the default starting port of 2000, just to avoid conflicts with the well-known ports ranging from 0 to 1023. As soon as I press enter, I'm being prompted for a password, which is secret. And you can see that I've connected to the backend router, and we're going to prove that by run enable conft and then all we're going to configure is its hostname, router 1. Save our changes. Okay, and to exit the telnet session I'm currently in, I need to press and hold Control and then press the right squared bracket followed by the quit keyword quickly. Otherwise the telnet session will resume and I would be reconnected to router 1. So now I'm going to run exactly the same command, but by appending the 2019 port to my command, like so. Once again, the password is secret. I'm going to run no enable conft and I'm going to run hostname router 2. Save my changes and exit, control squared bracket and quit. And finally, telnet 192.168.1.1, port 20. Secret is the password. No enable conft hostname router 3. Save the changes on this router as well. Type and exit, control and square bracket followed by quit. Close the window. And so if I double click on this router, we can see that its hostname has been set to router 1. Router 2 has been named router 2, and router 3 has had its host name changed to router 3, which proves that we were able to configure all 3 backend routers through a single centralized terminal server using reverse telnet. Thank you very much for watching.